Okay, here we are, CNT 125 IPv6 routing lab. A little bit different than the previous IP version 6 lab that we use. This one here using two routers, which means if we need two routers to communicate with each other, we're going to have to use OSPF. OSPF is a routing protocol. OSPF is also a link state routing protocol, which means both routers need to keep a database of knowledge of each other's networks that they're connected to. It gets more and more complicated as we move on into using more and more routers in our networks on how we determine who's holding the main database. But for now, this is just a point-to-point link in OSPF. So the conversation I'm going to have with you in a little bit about DRs and BDRs and druthers, it's going to it's not really going to apply to this particular instance. But let's go ahead and get ourselves started here. The first thing we want to do, obviously, is console into our router, bring up the command line, and then we are going to choose no on enter initial configuration dialog, and then get into privilege exec mode. And then when we have our router prompt at privilege exec, we're going to get into configure terminal. And then we want to change the host name of our router. So I'm just going to, you can call it top router, bottom router, depending on where you are in your configuration, where you are in the rack, and how you want to name them. I'm just going to name mine left router. So LR1, I'll call it. Works for me. So that's my left router. And if we were to take a look at the map that we have on our in our document, you would see that we have it all set up nice and pretty. Okay, there we go. I'm gonna make that nice and easy for you. So in here, this one's going to be the FC00. The way I did mine, I have the G01 interfaces connecting my two routers up here, and then I have my G00s dropping down into my networks. Okay, so first thing we want to do, we want to get into the interface of G0/0/0. If you're using the 2811, please remember you're using the FA/0s. Okay. Always know what inventory you've got in your router, so you know you're always programming the right one, or you're just going to be blindly following directions, then calling me over and saying, "Hey, mine's not working." So here we go. All right. So I'm interface 000, and I want to make sure that IPv6 is enabled. So we just run that IPv6 command. Then I want to add an IP address here. So we also want to say no IP address, because we don't want to do any IPv4 addressing. So by default, if you look here, it just says IP. So when that means there's no IPv4 address. But I do want to do an IPv6 address. I want to add one here, and it's going to be as I have listed in the map, and it's not case sensitive. So FC00:A::A::A. Right? Then I want to do a ::, and I'm going to do a /64 because it's a 64-bit address. Then EUI-64, and if you remember from my previous video, what the EUI-64 does is it goes into the interface of the routers G000, locates the MAC address, takes that MAC address, splits it into two, and inserts an FF and an FE in the center. Then it comes over to the far left, counts over in binary to the 7th bit, and turns it from a 0 to a 1 or a 1 to a 0. Hit my enter key right now, and now my address has been applied, but it's not up. As you can see by my map on the left hand side, it's all red going downhill there, right? So we're just going to say no shutdown, and you can see it turns green, and then right now it's talking to the switch, and so the switch itself is running a spanning tree protocol check to make sure we don't have a routing loop on that one. Next, I want to jump up here to my WAN interface on my to the network FC00:A::A::B. So we're just going to change interfaces here. So I'm just going to say interface. I don't have to exit out. Interface G0/0/1. No IP address because I don't want to do an IPv4. And then I want to do an IPv6 address of FC00:A:A:B //64 space EUI-64. Then do a no shutdown there. Now you'll notice if you're looking at the map, we don't have any green lights appearing up there yet, and the reason is because we have to program the other side of the router first. The link has to be available on both sides in order for that to occur. Now, we cannot do routing. If you remember from the previous video, we can't do routing in Cisco on the routers on IP version 6 until we declare it. So by the command is called unicast routing, and in IP version 4, IPv4 unicast routing by default is enabled. Okay, on IPv6 it is not enabled, so I want to do IPv6 unicast routing. It's dash routing, by the way. Okay, so it took my command. Cool. All right, and now I want to be able to communicate with the other router on the other side. So I need to do a routing protocol with that. So routing protocols are what routers use to communicate with other routers. Now, the first thing we do when we're doing OSPF is we want to set what's called is a router ID. Now, router IDs are important because in router IDs they determine who's in charge of the database, who's in charge of the link state database that tells everybody else, hey, there's been a change in the configuration. Everybody needs to make their database look like this one, because everybody who's on the in the map has to know everything about everyone in the area. So, or should say segment, not necessarily area. So in this case here, we are going to do a set up our router ID. Now on IP version 4, we set up our OSPF on the router, and then we declare the networks. What's really awesome about doing OSPF in IP version 6 is that we actually set up OSPF on the router's interface. And what makes that, in my opinion, more special is that if the network address changes, if you have to go in and make a change to the IP address on the interface, you don't have to go through and change your routing tables. It'll dynamically happen because we apply the OSPF to the interface. So you'll see that here in a second. Now, router IDs are set up for a purpose of managing who is going to be running the database. Because what happens is a router does what's called an election. So let me just give you a brief overview. So we have in OSPF, with the routers, we have a designated router, we have what's called a backup designated router, and we have what's called a druther. So who's going to be the designated router? The designated router is the boss. Okay. Now, in this instance that we're developing here today, we won't have a designated router because it's a point-to-point link. They're just always going to be talking to each other. But if I had to add a third router to this configuration, I would then, so for example, if I took another router and put it right here and then connected these two routers up here, I would then have to have a designated router and a BDR, okay, and a druther. But we don't have to choose those, okay? They can just happen, okay? And they do what's called an election process. So we won't need to do that today, but that's what the network would do. So first off, what is a designated router? Well, it's a special router that is elected on multiple access networks, like an Ethernet network. It optimizes the exchange of the routing information. If we didn't have a designated router, every router on the network would need to form adjacencies with every other router. So if I have 10 routers on this network, my left router over here would have to form an adjacency with every single router, and that's not an efficient way to do it. It's too much overhead. So we'll have to what we call is form an election process of who is going to be the designated router. So the DR, the designated router, will act as a central hub for all of our OSPF communications. It performs the following functions here. Okay, it's going to establish adjacencies with all the other routers on the segment. Then it's going to collect a link state advertisement. So every router is in communication with every router, that it's connected to. So it's their linked state, right? So what's going to happen is I'm going to be able to say, hey, I'm connected to network B, I'm connected to network A, I'm connected to network C. And if one of those networks goes down, we will inform, those routers will inform their neighboring routers, hey, I'm no longer connected to C, let A know that you can't get to C through me anymore. That's how that whole thing works. Okay, so it collects the link state advertisements from the other routers, and then it distributes them across the network. It maintains a complete link state database for the segment and then generates network LSAs summarizing the map, summarizing the topology. So then we have to have a backup. Okay, you always got to have that redundancy in here. So we have our backup DR, or backup designated router. It also, is elected alongside the DR. It acts as a standby, so if the DR fails, it'll take over as the DR. It maintains adjacencies and a synchronized link state database in case the other one goes down. But it's not the one who distributes the link state advertisements. It just maintains a copy of them. And then if the main database goes down, then it becomes a designated router, and then it will be able to perform those functions because it already has all that information. Right? So how does the election process actually work? How do we know who's going to be the DR? Well, it occurs during the initialization process of OSPF. So, one, the priority. We can set an OSPF priority. Each router interface has a priority value. The default is 1. It ranges from 0 to 255. So whoever's got the highest router or the highest priority, they're the DR. But by default, it's 0. So right now, router 0 in our config here, router 1 in our config here, they both have a router priority of 0, which means it's a tie. So the next thing we do is we say, okay, who has the highest router ID? Now, router IDs look like IP addresses, but they perform no real function, other than setting up a priority or who's going to be the DR. They don't do any routing. It's not there for that. It just looks like a 32-bit IP address. So we could say, all right, left router on your map is a 2811. So 2811, it's an older router. It's not going to have the processing power that the 4221 has. So I probably wouldn't want to set that up to be my designated router. I would want him to be the backup designated router. So I would give him a lower priority. So I would say, okay, he's going to be 1.1.1.1. Okay, that's one way to set up that example there. Another one would be, another way to determine if I didn't set up my router ID, it would be which router has the highest loopback address. Now, we haven't really done loopback addressing in CNT 125, but if I were to do interface L0, okay, or interface loopback 1, okay, then I would have a virtual interface called loopback, and I could set a higher ID on that one if I wanted to do it that way. And the other one, if I don't do the loopback address, if I don't do change the priority, and I don't set a router ID, Cisco routers will then use who's got the highest IP address number. Right. So those are some pretty much how the router IDs will get put into play there. Okay. So that's how the election occurs. Okay. So some things you want to look at, okay? So if, in that case there, if we had a router 1, router 2, and we add that third router, router 3 would become what's called a druther. Now a druther it's not a designated router, it's not a backup designated router, but it will form an adjacency with both of them, okay? Now you could influence the election and say, I want to make sure that my 4221 router becomes the designated router. I could do it two ways. I could just make sure that I give it a higher router ID, or I could right out of the gate say I could type in the command in the interface. So I go to interface G0/0/0, okay, and then do IP OSPF priority 200. Because remember, the priority numbers can go from 0 to 255. The highest one is going to win. And by default, they're all 0. After you change your priority, then you just have to reset the OSPF process. You can do it a couple different ways. You can, save your config and then restart your router. Or you can type in clear IP OSPF process at privilege exec prompt and do it that way. Okay. So now let's get back into programming our routers, because the next thing we want to do, and the reason I brought this up, is I want to now go ahead and give myself a router ID. Okay, so in regular configuration mode, okay, global config, I'm going to do IPv6, okay, because we're doing it's IP version 6, and just so we understand, by default your router does OSPF version 2, IP version 6 does OSPF version 3, right? So we're going to turn on OSPF. We're going to say so IPv6 router, because when we do IPv4 it's just router OSPF, and then in your lab we're using 2. I always use 10, but I'll go ahead with your lab. OSPF, okay. 2 is just the ID number, okay. So now it says, okay, we're doing OSPF version 3 because it's version 3, right? So it's IPv6. So it could not pick a router ID, so it wants you to create an ID. All right. So in this case here, I'm going to say router -ID 1.1.1.1.1. There's no subnet mask because it's not a real address. It's not a 32-bit address. Okay. Now we're going to exit out. So now my router is capable of running OSPF version 3 for IPv6. I want to get back into my interface of G0/0/0. That is my A network over on the left-hand side. And I want to configure this interface to be operating in OSPF version 2 in area 0. So I'll say IPv6 OSPF 2, because that's the one we chose up here earlier. We configure for our router, and it's going to be in area 0. If you remember when we did the IPv4, we did the OSPF, but we did it just in router config mode. We didn't do it on the interface. In IPv6, we set it up on the interface, so whatever has to change, it'll change. So now we have set the interface, okay, to enable OSPF routing, okay. And now we could actually, if we wanted to, okay, we can let's go into the other interface. Let's go into interface, because we're going to set both these interfaces to run OSPF version 3. So now I'm in G01. I'm going to do IPv6 OSPF 2 area 0. All right, so now both interfaces have been set to run this. All right. So if I do a show run now, we will see, okay, that we are running IPv6 unicast routing right here. We also see, okay, that we have our IPv6 address listed right there. We have our WAN interface there, and you'll see that both of these are running IPv6 OSPF area 2 in area 0 on both of those. So both of those are set up to run. Okay. We can also see in here that our router itself is set to run OSPF 2, and our router ID is 1.1.1.1. So all the changes that we put in there are all listed in here. Okay. Gives us the opportunity now to go ahead and do everything that we have here. We're going to do it all on the other router. Let's see if we remember what we're doing. Big T, host name. I'm going to left router 2. No, it's right router. Ooh, right router. All right. Let's go right into our interfaces of G. I'm going to do the one that's connecting the WAN right here across the way. So I like to see that nice line turn green right here. Okay, so I'm going to do G0/0/1. No IP address. IPv6 address. And it's FC0/A:////64 EUI-64. Okay. And I want to do a no shutdown here. I'm also going to jump into the interface of G0/0/0. Do the exact same thing. No IP address. And then I'm going to do an IPv6 address of FC0/0:A:////64 EUI-64. Right? And then do a no shutdown on that interface as well. Okay. So as you can see now, the WAN configuration, we're green the whole way across the board here. It's really cool. Next, I wanted to set up OSPF on this router here. So I'm going to drop myself back down to privilege exec mode by typing in exit. I'm not privilege exec, just global configuration. And I want to do my IPv6 unicast routing. Hit my enter key. I want to now set up the OSPF on the router itself. So I have to do IPv6 router OSPF 2. You'll notice once again It doesn't have a router ID, so I'm going to have to give it one. So it's router-ID, and we're going to do 2.2.2.2. Now, because on your maps you're using the 2811 and the 4321, so what you've done here, if this were going to be using a designated router and a backup designated router, this would have the higher priority because he has the higher number. Okay. I'm going to exit out of here. I'm going to get back into my G0/0/1 interface. And now I want to set up on this interface interface G0/0/1 IPv6 OSPF 2 area 0. And then I want to get into my interface of, you'll notice it just configured my adjacency to the first one, so it learned that. Now I want to get in my interface of G0/0/0, and I'm going to do the same thing, IPv6 OSPF 2 area 0. Now, if you remember from the IPv4 labs, we always had to, like, after we did OSPF, we had to drop down and then type in all the direct networks that we were directly connected to, so that we could share those. We don't have to do that with version 6 because we applied OSPF to the actual interface. Now the interface are talking to the router and the router is talking to the others. So we don't have, so if our network IP addressing changes, we don't have to go in and reconfigure OSPF. It's already done. It's so amazing that way. Okay, so now we have all these set up. Technically they should all be able to communicate with each other. So let's go ahead here and let's do exit. I'll exit again. And now I'm going to do a show IPv6 route, similar to a show IP route, but it's for IP version 6. Now notice I have right here the O. That means I learned about the A network, okay, via, okay, the B network right here. So OSPF is working. So let's see if we can get this guy here assigned an IP address. Now I already went in and did the headache of setting up, finding out what my MAC address is, because we're going to use the last 6 digits of our MAC address right here. And on this one over here, I'm going to switch up the lab a little bit. So I'm going to do something called SLAC, which is stateless address auto configuration. And it kind of acts like an IPv6 DHCP. It actually, in my opinion, works better. So let's just go ahead and do the first one the way you guys have it in the lab. Okay. We're going to go to our desktop. I'm going to go to the IP configuration component of it. And we're going to do the FC00:A::A::A::. All right, and now we want the last 6 of our MAC address. You see it's sitting right here. Okay, you could also just drop it in the command prompt and grab it right there, but I already did that part ahead of time. So I'm just going to do the looks like it's 95:. Oh, my bad. I'm in the IPv4. Let me fix that. So it's FC00:A::A::A::. And then we're going to do the last 6 of our MAC address. So that is going to be 95:C1:1D. The default gateway The default gateway is this guy's address. So we have to go and get him, okay, get his address. Let's bring him up. Let's do a show IPv6 interface brief. And I need to get this guy's address right here. Select it. Come down to the right-hand corner of your page here and click copy. Then we're going to go back to our PC over here. And we're going to paste that into there. So now he is all programmed up. Pretty cool. So let's see if it worked. Let's see if we can ping our gateway. Him right here. Let's see if we can ping him. So we'll ping. Should be on my clipboard. We'll paste it right in. And I was able to ping my default gateway. So now we know that part, that component right there is working. I'm now going to come over to this PC over here. And we're going to use Slack. So what Slack does is it just simplifies a little bit of your addressing to make it more a little more efficient. It frees up the occurrence of typos because an IPv6 address is rather long. So what we need to understand is that our routers, okay, when they're online with IPv6, they're doing something called a router advertisement, and your computer wants to be handled as well, so it's doing a DHCP advertisement, so or request. So what's happening is your router saying, hey everybody, I just want you to know that I'm the router, and if you want to go anywhere other than just on our network, you need to go through me. I'm the default gateway. So here's what I'm going to do for you. I'm going to let you know what my IP address is and what network I belong to, because that's the first 64 bits. And then if you want to communicate, you're going to have to set up your IP address, and you're going to have to make sure that you're on my network if you want to talk. How you do your host address, I don't care. That's up to you. So I could pop into here. Go to my IP configuration, and I could say, all right, it's FC00 colon, all right, and then do A colon C colon, and then go, okay, what's my MAC address? It's going to be 4E colon 57 colon 33. I could do that, but then I have to go and get the rest of my information. Okay, and put my I forgot to do my 64. Okay, I could put all that in there. I could, or I could go like this. Hit automatic. Check it out. It even filled in my default gateway for me. It got the information via Slack. The only thing it's not a DHCP server. It's Slack, stateless address auto configuration. Now you can see here that it actually did use your the MAC address here with the 4E, okay, 5733. It did use that to create my address. Okay, didn't need to, but it did, and it did in EUI 64. How you get that address, way that address will be configured will be based on the operating system that you're using, whether you're using Linux, whether you're using Windows, whether you're using Apple. All right. The operating system will determine this type of security. But that's two different ways that you guys can get those addressings. And in essence, that's our lab. So I should be able to now take this address. Let me go to my command prompt. We'll see if we can ping it from the other side, right? Let's close out of him. Go to our command prompt. Let's do an ipconfig/all. And here's my IPv6 address. Let's just copy him. I'm going to come over here. bring up his command prompt. We're going to ping. All right, so that's the A network. That's not the one we want to be pinging. Let's see what we got here. Might because of the might have to type it in. Let me see. See if I can cheat. It's not gonna let me. It's not gonna let me grab him. I'll write him down. Okay, so it's 202 16FF FE 4E 5733. All right, so I'm going to hop over here. Destination host unreachable. Let's see why. I think I might know. Should have gone. We have IPv6 unicast routing. Maybe I have a typo in my addressing. There's my error. Typo right there. Nope, still unreachable. Interesting, Mr. Bond. All right, so I figured out what my problem was. My problem was right here. I had neglected to type in, so you notice my error message is up here where it replies back from the FE80, destination host unreachable. So let me show you why that was happening, because I made an error. So on here, when I plugged in my IPv6 address, I did not put in my 64-bit over here, so it didn't put anything. So I only had the capabilities of communicating on my own network. So I fixed that, put in my /64, so now it knows what to do. I can hit my up arrow, hit my enter key, and I can ping from point A to point B without problem. Piece of cake. All right, so that is the IPv6 lab. Hope you enjoyed it, and I will see you all shortly.